Let's be honest, trying to get AI into your Java apps, man, it can feel like you're lost in a maze, right? But what if you had a guide? One built on a foundation you already know and trust. Well, let's talk about that guide, Spring AI. So if you're a Java developer, this probably hits close to home. You see all this incredible power with large language models, but just getting started, it feels like a total maze of obstacles. You're ready to build cool stuff, but it's like, where do you even begin?
And it's a real maze. I mean, think about it. Every single AI provider, OpenAI, Google Gemini, you name it, they all have their own SDK, their own weird authentication dance, their own way of formatting responses. And what does that lead to? A whole bunch of duplicated, vendor-specific code, which brings up that one thing we all dread, vendor lock-in.
But just imagine for a second, what if you could just slice right through all that complexity? What if you could navigate this whole maze with one simple, consistent thread? A thread woven from the exact same principles that make the Spring ecosystem so awesome and productive in the first place. Well, that guide is Spring AI. It is the answer for enterprise Java teams who want to jump into generative AI without having to, rewrite the entire rulebook. And this right here is the best way to think about it. If you've ever used Spring Data to talk to different SQL databases, you already get the core idea of Spring AI. It's that simple. One consistent programming model for a whole bunch of different AI providers. So here's the really important part. Spring AI isn't trying to reinvent the wheel here. Not at all. It's just taking that time-tested Spring philosophy, portability and modular design, and applying it directly to the world of AI. It gives you this one unified API to connect all your enterprise data and services with AI models, which means you get to focus on building cool features, not wrestling with glue code. Okay, so how does this actually work in practice? What's that first step look like? It all kicks off with one simple but really powerful component. Okay, this is the aha moment. Look at the left. That's the old way. You're wrestling with HTTP clients, building JSON by hand, parsing all the responses. Ugh! Now, look at the right. That's the Spring AI way. A super clean, fluent API, the chat client, that just handles all that junk for you. That one little line of code, it replaces all that messy boilerplate. It really is that simple. All right, so a simple chat response is cool, but let's be real, real-world apps are a lot more demanding. They need to have a memory, they need context, and they need to actually do stuff. So let's take a look at how Spring AI helps us conquer the three big trials of AI development. First up, we've got the trial of amnesia. By default, these language models are totally stateless. They have zero memory of past conversations. You could tell it your name, and in the very next prompt, ask, "What's my name?" and it would have no clue. So how do we fix this? Spring AI gives us a really clear three-step path. First, you just configure a repository to save the chat history. Easy enough. Second, you add an advisor, and you can think of this like a smart little interceptor that automatically loads and saves the conversation for you. And third, all you have to do is provide a unique ID to link each request to the right conversation. And just like that, problem solved. Memory unlocked. Okay, next up, we face the trial of ignorance. Your AI model knows a ton about the public internet, right? But it knows absolutely nothing about your company's internal documents, your product specs, or any of your specific domain knowledge. How in the world did we teach it? The answer is a really powerful pattern called retrieval augmented generation, or RAG for short. Now, the idea is actually pretty simple, but it's totally transformative. Instead of trying to retrain the entire model, you just retrieve relevant little snippets from your own data, and you stuff them right into the prompt. This grounds the model's response in your specific private information. And here's a look at how that RAG flow actually works. A user asks a question. That query is then used to search a specialized vector database, which is just a type of database that's really good at finding similar concepts, and this database contains all your private documents. The most relevant pieces of text get pulled out, and then they're combined with the original question in a brand new prompt that gets sent to the LLM. The result? A super accurate, context-aware answer that's based on your data. And of course, Spring AI makes putting RAG into practice incredibly straightforward. It gives you a portable API for over a dozen vector stores, a whole ETL framework to process your documents, and even a question-answer advisor that pretty much automates the entire RAG flow for you. It's all there. All right, our final challenge is the trial of helplessness. An AI that can only talk is, well, pretty limited. So how do we empower it to actually interact with other systems, to call APIs, to, do things in the real world? The solution here is called tool calling. The idea is you describe your Java methods to the AI model, and then, based on the conversation, it can intelligently ask to run them. And in Spring AI, this is ridiculously simple. You just take a standard Spring Bean method, you add the @tool annotation, and you give it a clear description of what it does. The framework handles everything else. So, we've built a pretty smart app. But is it ready for production? Well, Spring AI carries forward that same production-first mindset from Spring Boot, so the answer is a big yes. Oh, absolutely. It's built for the enterprise from the ground up, with 3 key pillars in mind. Observability, so you always know what's happening. Scalability, so it can handle real-world load. And performance, for being super resource efficient. Let's just touch on each of those real quick.
First, observability. Look, AI calls can be expensive and sometimes unpredictable. Spring AI integrates directly with Micrometer, giving you metrics for token usage, latency, and more right out of the box. This is absolutely essential for monitoring your costs and performance when you go live.
Next up, scalability and performance. Since AI calls are mostly just waiting on the network, you can use Java's new virtual threads to dramatically boost your throughput, and you can often do it with just a single line in your configuration file. And for maximum efficiency, you can compile your app to a GraalVM native image for blazing fast startup and a teeny tiny memory footprint. Okay, we've covered the fundamentals, but these building blocks let you create systems that are way more sophisticated. So what else is possible? Where can we take this? This is where things get really, really interesting. You can start building these advanced agentic patterns. A chain workflow, for example, can break a complex problem down into a sequence of smaller steps. A routing agent can use an LLM to figure out what the user wants and send it to the right specialist tool. You can even build these crazy complex orchestrator, worker, or evaluator optimizer systems where multiple AIs are all working together to solve a problem. The framework gives you all the tools you need to compose these sophisticated workflows. So we've come full circle. That AI maze, it doesn't seem so intimidating anymore, does it? With Spring AI, you have a clear, reliable guide that uses the tools you already know and love. The path is clear, so the only question left is, what will you build?